Viste que se inundó Dubái.
Vi que un centro comercial, no sabía que todo Dubái. ¿Cómo se inundó?
No, una tormenta así de la nada. Bueno. Welcome back. This is another episode of Developer Aligned, a live stream series made for the contemporary open source Anon contributor. That's you. And today we have a special episode. This is Intro to Sway for JavaScript developers live from Giveth House. This is in Barcelona. I'm here for Web3 FC. And as a side event, we decided to put together this amazing event, which is having by the first time our hybrid format, which means we have in-person hackers doing the workshop, and then we have you in the live streaming. So let's begin with Intro to Sway. So Intro to Sway comes from actually our own documentation. So you can access that by going to this URL. There you go. And basically docs.fuel.network/guides/intro to Sway. Well, let me, okay, this is better. Yeah. So intro to Sway, we have the prerequisites section, which was shared beforehand with the attendees. Then we have the import section, we have the structs section, we have the ABI section, we have the storage, errors, function. Then we have a checkpoint. I think we are going to make it up to this stage for this show, but you have as a home assessment implementing the Rust unit and E2E testing, and the TypeScript front end. So let's begin. Okay, so this workshop assumes that you already have installed both Rust, CLI toolchain, and Fuel, which come in the form of Fuel Up. So the first step is to go to your terminal and create a new folder, which I already have, which is this folder, Intro to Sway. As you might see, we have nothing there yet, just yet. This seems like a better size. Okay, then we go into that folder. We are there, and we are going to create a new contract. So I come here and I place fork new contract. So fork stands for Fuel Orchestrator, and this is the CLI application that will help us to manage our code, toolchain plugins, and so on. New is the keyword, the command that instructs the fork orchestrator to create a new Sway contract, a new boilerplate for a Sway contract, and then the name of the contract. So for this case, I'm going to use intro dash contracts. There you go. So if everything went right, I should move my face from here. Okay, give me 1 second and let me move my face because this is better. Yeah, this is way better. This. Okay. So if everything went as expected, you will see a prompt that says, read the docs, join the community, and so on. So this means we have everything in place. So let me clear the screen, list our folders, and then you will see we have the Intro to Sway contract, which is the folder made by the Fuel Orchestrator. We go inside, and when we do ls again, we will see we have 2 files. The first one is the fork.toml, which is the manifest for the contract and seems really similar to what you get in Rust. And then you have the source folder, which has our code. So let me go 1 step behind and code this. And I have the code here as well. So let me take this to my own screen. Yep, so I can do some cheating. Yep. And I use this one for you guys. Okay, maybe a little less. Okay, this works. Okay, so we have, as I told you, our manifest file, and then we have our source code. So if I go to my okay, this one. If I go to my own terminal, remember I am inside of the contracts folder and I run fork build, I can get a compilation of this sample contract. So right now this is compiling this code, which is the boilerplate code that comes with the scaffolding from the Fuel Orchestrator. Okay, so let's go back to the guide. So as you can see, we have the same folder structure. We are inside the contract. So let's begin by deleting everything from this file. I'm going to the Sway program statement. So basically, we are using one keyword here to tell the compiler which kind of artifact we are building. So in Sway, we have contracts, we have predicates, which is our own stateless, a kind of abstraction implementation. We have scripts, which are libraries, Sway library, and Sway libraries, and then we have scripts, which are on-chain artifacts that basically perform action. So if you are willing to do some like hacker DeFi and create an LP position and then liquidate something else or do some kind of crazy arbitrage, a script might be the way to go. But for this case, we are using the contract. Okay, so let me save that. The next step is to start doing some imports. So the Sway standard library provides several utility types and methods we can use in our contract. To import a library, you can use the keyword and double dots, also called a namespace qualifier to chain libraries like this. So basically, this is a Rust standard import. And we can use these in our contract to start importing. For instance, here we are using from the standard library the authentication module, and we are using message underscore sender, which is basically the information of the account who is sending the transaction. But we can also use curly braces to import multiple objects or interfaces from the same for multiple libraries. So from the standard library, we are using a message sender from the auth and storage vector from storage. But in the case for this contract, we are using these imports. So it is message sender, message asset ID, which comes from call frames, base asset ID, which is a constant that specifies the base underlying asset. Please remember that the field VM is asset agnostic. This means that you can use every kind of asset to pay for gas and stuff like that, like in a native way. So it's like you don't have to use ERC20 contracts by default, but you can use just built-in methods. So the base asset ID will be like, for this case, the ether. Then from context, from execution context, we are getting message amount and this balance, which is the balance of this account, this contract account. The transfer method from the assets module, this is like the interface that allows us to control the native asset system, and the hash, just plain hashing. So let's go with this. If we try to compile this project, let me get a drink. You will see that we have a successful compilation. So we can move forward. Let's go for structs, which is basically the way of defining complex data structures. So it's a data structure similar to an object in JavaScript, and you can define a struct with the struct keyword in Sway and define the fields of a struct inside of curly brackets. The core of our program is the ability to list, sell, and get items. And this is a nice moment to start giving you some context. We are building a marketplace. Just basic Amazon stuff, like really basic. This is listing assets, selling assets, and so on. So let's define the item type as shown below to write in your main.sw file. So let's copy this from here and place that just right here. So we have our contract statement, we have our imports, and then we can start defining structs. So for this case, we have the item, which has an ID, which is a unsigned integer of 64. We have price, we have owner, which is, this is a special type, which is identity. As you can see, is an enum, so basically it's address or contract ID. We have metadata, which is a string of 20 characters, and we have total bought, which is the total amount of items of this specific item that were sold. If we go to the compiler and try to build, we will get some warnings. And these warnings are, you have an struct that is never used with properties that are never used. So very helpful compiler. This comes like, this is a standard practice from Rust, which is having an amazing compiler. So let's move on. Here in the original guide, which is docs.field.network/guide/intro to Sway, you have a more detailed explanations of the use types, but we are not going into that. We are moving forward into the ABI. So Next, we will define our ABI. ABI stands for Application Binary Interface. This is because on-chain, every contract is just bytecode. So for an external software, there's no way to actually know which methods are available to call. So in order to be able to interact with on-chain artifacts, this applies for mostly any blockchain, you have to use an ABI. So the ABIs is just an JSON object that tells other services how to interact with this on chain code. For the case of Sway, we have a declarative ABI. As you might know, for Ethereum, you have like generated ABIs. So you just create your own code, and then you have an ABI file that you use to interact with SDKs and so on. For Sway, ABIs are also interfaces within the code. This means that I can set this ABI into its own file and use that, like exchange that with the world, so everyone else can do their own implementations for this. And it's very helpful because as soon as you define the ABI and keep that ABI, you will be able to basically have multiple implementations. So you can have like Sway Store V1 or Sway Store V2 and so on. But for this case, we are copying this and having a closer look right now. So after defining our item struct, we can go and define our ABI. So this ABI is called Sway Store and have multiple methods. The first one is list item. As you can see the description here, a function to list an item for sale, takes the price and metadata as arguments. Very important is that for Sway, we have these annotations. These annotations can basically tell the compiler which kind of scope is going to have this method. In this case, we have that list item has access to storage, specifically the ability to read and write information, and has two inputs, price as U64 and metadata as a string of 20 characters length. We also have by item that has the ability to access, like read and write the storage, but also has the ability to receive funds. This is like the basic payable you already know, like the modifier you use for Solidity. Well, this is it. So having these annotations allows this function to receive funds. Like if you try to send some money to by using this method, you won't be able. Like you can only transfer funds when interacting with this method. Then we have a getter, which is get item, that just reads. Something really cool is that you can have a method that just writes, not reading. So I think it's cool. Then we have initialize owner because we want this contract to have an owner. Then we have the ability to withdraw funds, like basically giving the funds back to the owner, and get the number of items listed in this contract. So we can save the ABI and build this contract. So there we go. So far, so good. And I think it's something important to mention is that we are building a contract, but up to this point, we can be working into a library. This means that this code is not a contract and is something we can store stateless in our own file system, and we can basically upload this to GitHub and creating a new contract file and importing information from this library. So we can define this struct item and this ABI in a separate file, call it a library, and then go to a contract and import these structs. So very useful but for this case, we are not splitting the code. We are keeping everything between the contract file. So let's move forward. So we have like a detailed explanation on the functions structure. You know that. Let's move with the storage. So this storage block, I think this is one of my favorite features from Sway, which is being able to define this storage on a separate block. So for solidity, we have just variables and we interact with those variables, and sometimes it's hard to know whether you are using a local variable or a storage variable. For the Sway situation, we have that we are required to define a storage block, and this is the interface to interacting with that contract. That means that we can basically use the storage methods in order to know every time that we are doing a storage operation. So let me take this storage, place that into our own code, and take a quick review. So basically, we are just taking care of three variables. The first one is the item counter, which is the total of listed items, and we can access this variable by using this getter. Then we have a mapping, as you know, which is a storage map, a dictionary just as any other, with item IDs and item. Why is this a U64? Well, because our item struct has a U64 as an ID. And finally, we have the owner, which is an identity. The option wrapper is because we have enum, which is address or contract ID. And we are initializing this as known. So this is like nulling the item. Here we are declaring a empty storage map, and we are using a 0 for initialization. It's important to notice that we are defining the storage block by adding keys, types, and props, and then using commas to split each one of these. So let me come to my terminal and do another compilation step. And it's working. So far, so good. We have many warnings. The first one is that the struct item is not being used. And regarding the storage block, we have warnings regarding that all of these storage entries are not being used yet. So we have like more detailed explanations on these types, but let's move to error handling. So enumerations, commonly referred as enums, are a type that can represent one of several possible variants. Within our contract, we can employ enums to craft custom error messages, facilitating more precise error handling within functions. So here we are defining an enum to basically include any kind of error we are having in our application. So in this case, we are having incorrect asset ID, not enough tokens, and only owner. And for each of these cases, we are basically defining return types. So incorrect asset ID kind of errors are going to return the asset ID. Not enough tokens are going to return like the amount. Yeah, the number of coins involved. And for the only owner, we are going to return the sender, like this is the identity you sent and is not what was expected. So it's not that we are exposing the true owner, we are just returning the like wrong owner. Okay, let's start implementing functions. So the first step is to define an implementation. So let me come to my own Sway manifest, which is this one. And we are going to implement Sway store. So basically we are going to implement this ABI for this contract, and I'm using yeah, it's for contract. So basically I'm saying that this ABI is going to be implemented for this specific contract. So we are using curly braces, and we start by defining like just the boilerplate of every function. So basically we are using we are going through like all of our ABI definitions and implementing functions as described in that ABI definition, but we are adding the curly braces after that just to start writing these implementations. If I'm willing to compile these, I will get errors. Why? Because this function should be returning something, but it's returning nothing. And that's something that the compiler doesn't like at all. So let's run fork build. And then you have the errors. So it's basically saying that you should be returning this, but you are returning nothing. Okay, I have some comments, people reading. Okay, hi to you. This is Edson from Brazil. We have a lot of Brazilian engineers, so welcome. Okay. Let's continue. Let's come back to our code here. So we begin by listing a new item. So basically, this function enables sellers to list an item for sale. They can specify the item's price and provide a string that references externally stored data about the item. So let's begin by taking this line of code into our own code, this item, okay, and place that. So increment the item counter. So we go to storage, access the item counter, and tell the compiler that we are going to write into that storage slot, and we are going to write something. So it's like I can just place 5, and this is like an arbitrary value I'm writing, but actually I'm just placing a read operation, which is this one, storage dot item counter dot try read, and this is basically a wrapper to avoid committing mistakes. So in a regular, like I may say, robust implementation, I will be first having like the current value, just like this. And then I will be performing this reading operation. And then I will be, wow, a lot of symbols. Which one is this? This one. And then I will be performing this operation, and then I will be using a match statement to unwrap this item in order to like handle any possible errors. But in this case, for the sake of simplicity, hello, Sammy. So Sammy is one of the managers of the Fuel Spanish community, so you're welcome to join. So for this case, we are not doing like this kind of sophisticated behavior. We are just taking this read operation and adding the unwrap method, which is well known to Rust developers, which means basically we are just ignoring that this execution might fail, and in case of failing, we were just having a reversion. We are ignoring that. We are not handling that error. That's what unwrap means. So I'm taking this, expecting that the value is there and expecting that nothing goes wrong, and I'm placing this here. So that reading operation I just did, it's going to evaluate into a number, and this number is going to be added with this one, and having finally like whatever number is there plus 1. So in the first run of this function, we will have that this execution is equal to 0. Then we are going to add 1, and then we are going to write that into the item counter from the storage. So that's the first line. Then we get the message sender, which is something that you might already know from Solidity, which is basically getting which identity, as you might see, is making the transaction. Finally, we are going to instantiate our item struct. So we are creating a variable of type item, and we are using the item constructor to create an struct with these parameters. So for ID, we are using our item counter. So we can actually take this one and say let current item ID to be equals to this. Yeah, and we are using this one. Let me add some padding this, and we can use this variable here, and we can use that here as well. Finally, we are going to save that new item into our storage. So basically, we are taking, again, the storage object, the item mapping, which is the dictionary containing all of the items, and we are going to insert the current item ID in that position. We are going to create a new item. So basically, in this function, the first time is going to create the item number 0, which is retrieving this from our storage initialization, which is right here. It's going to take that 0, and it's going to create a new item, and it's going to write that item in our mapping on that position, number 0. But before doing that, it's going to write the new ID as 0 plus 1, which is 1. So we defined our first function. We can try to run this like in order to see if we don't have any errors. So let me actually just take this away for the sake of simplicity. Okay, yeah, I cannot take this out because I'm going to get a different error, which is you're not implementing every method for the API declaration but for this, in this case, we have like all of the previous errors, which is you're trying to have functions returning something, but you are returning void. So that's the wrong typing. But beyond that, we don't have specific errors regarding our own method implementation. So moving forward, okay, yeah. So we have the message sender explaining what's below result enum, which is rather an okay return or an error, but we are just using unwrap because we are not taking care of those errors yet. Moving forward, we can't buy an item. So this is like a more complex behavior. So we are going step by step. So let me get up to this point, just right here. So buying item. So no, okay. So first we get the asset ID for the message sent. So basically we are getting this method that is telling us from the transaction context, which is the traded message ID. We are verifying that the asset that is going to be sent is the same asset that we are expecting. For this case, we are expecting the base asset ID, which is Ether. Otherwise, like if this condition is not met, we are returning this error that says invalid error, incorrect asset ID, and we are returning the sent asset ID. So basically, we are telling the user, hey, you sent the wrong asset. You are sending this asset, but is not the one that we are expecting. Then we are taking the message amount, again, for the transaction context, which is basically stating the amount of this asset that was sent with this transaction. And then we are retrieving an item. Which item? The item that is requested by the function execution. We are again trying to read, and then we are just ignoring any possible errors. This is like not the safest pattern for Rust. Like in Rust, you should be taking care of these issues. But one of the security aspects of Rust is that you know beforehand where the code is meant to fail. Like if you see any unwrap in your code, you know that maybe there is the crashing. So after getting the item, we are going to first retrieve that. Um, so we already got the item. So we are required that the amount that was sent is more or equal to the item price. Like I should be doing equal, because I want people to like send the same value. But in case I'm willing to accept tips, I can say more or equals to the item price. Otherwise, I will tell the user that you don't have enough tokens, and I'm going to show you how many you have. Finally, we are increasing the total amount of items being sold. As you know, when we define our item struct, we establish that each item has a total amount of sold items. So for this case, we are writing the current item ID and adding a 0. Oh no, this is not. That's here, yeah. We are reading that information and we are adding 1. Remember that when we create each item, we are setting that value to 0. So we are taking that 0, adding 1, and basically inserting that structure. So the structure we got, the structure we mutated, and we are writing that structure in the same position back again into the storage. Finally, we are charging a commission. So in case that the amount sent is greater than 1 ETH, we are getting a 5% commission from the sale. And we are sending the payout to the seller without the commission, or in case we are getting less than 0.1 ETH, we are sending the whole amount to the seller. That in this case is the owner of the item. We can save this and move forward. Then something pretty straightforward, which is returning an item. So as I told you, you should be studying this in one function and then using a match statement in order to like handle possible runtime errors. But in this case, we are not doing that. We are just going straight forward with the unwrap, which means I don't care about the danger. Just give me what you have. And this is effectively returning what the function expects. If I just delete this, I will get this error, which is this path must not return a value of type item from function get item. But it's not like, but if we give the right type, compiler will be happy. Then we can initialize the owner. This is like an explanation on Rust implicit returns. We're not doing this right now. Let's set an owner for the contract. So we will get an owner from the contract storage. We are required that is none. So we are basically verifying that this contract does not have an owner yet, because as you know, when we define our storage, we set it a default value of none. So when we initialize the owner, we are required that the owner is known. And if this condition is not met, we are returning this error, which says owner is already initialized. If the owner is not initialized yet, we are going to retrieve the identity from the message sender, again, not handling a possible error, and then writing that information into our own storage. So basically, you are setting that option. It was a known, now is something, and this something is an identity, because that is what the storage says, an option that maybe is an identity. So now we are saying that, yeah, it's something, it's an identity. In this case is sender. And then we are returning that sender. So in Rust explicit return will be like this, but yeah, this is something we understand, right? Because as a JavaScript developer, you have like optional semicolon. It's not the case for Rust, is not the case for Sway. You have to write this every time, because otherwise you're returning this value for whatever is the upper scope. So actually, because this is a void function, I can just like return a number here, and this will be complete. Like actually, I can come back here and build our code, and yeah, we have the compilation, and it's actually giving us some information. Basically, this is telling us that this is being never constructed in the code. This is telling us that we are not accessing the storage as we said we were going to do. And this is telling us that this function is empty and should be removed. But hold on, because we are defining that, which is this one, the withdrawal. So let me come back here, paste this code here. And yeah, so we are reading the owner from our own storage.owner.try_read. Not caring about the errors. If the owner was not initialized, we are returning an error because we need somebody to send money. Then we are getting information from the sender, which is the people asking from the transaction, and we are making sure that the owner of the transaction, the owner of the contract, is the same identity who is doing the transaction. Basically, if you are trying to get all the money from this contract, you should be the owner. Otherwise, we are telling you, hey, only the owner can do this, and you are this identity, not the owner. Then we are having, ooh, we have somebody ringing there. More people coming. Okay. So we are getting the balance from, oh, we have somebody loving fuel here. Thank you, Georgie. Then we are basically requesting the current contract amount and verifying that the current contract amount is more than 0 tokens, and finally sending that money to our owner. So please note that we are not using the sender, but the owner for the transfer execution, which is like an additional layer of security. We can now come back, build this. Oh, so the pixel is here. Great news for us. Yeah, basically, finally it's telling us like there's no issues in this code at all. The last issue might be that we are using a function that is not reading the storage as they said they will be. So we can fix that by adding a proper return that is actually getting into the storage, going into the item counter, trying to read that and ignoring any possible errors. And now is when we can build this and have a successful result. So as I told you, we were going to reach up to this point, which is Sway contract checkpoint, which is basically telling you, hey, you should be having a code like this, which is what we have today. And it's telling us that we can format our code. I'm not doing that. Why I'm not doing this? Because in my Visual Studio Code, I have actually the Sway extension for VS Code. So this helps you to have like a static analysis of your code. Like basically is reviewing that your code is have like proper syntax and doing some formatting and so on. So I'm not running like this comment every time because this is being done by VS Code with this extension. We already built this, which is the result of the compilation that you can see here is like with no issues. Something important to notice is that here we have one size and here we have a bigger size. That's because we added more information into our code between those buildings. So yeah, congratulations, we did it. We had a full contract in Sway. Post compilation, the system will generate ABI.json, which is like the JSON version of our ABI, storage slots, which is containing the information of the initialization values for our storage, and a contract binary, which is the information we are going to upload to the blockchain. And you can find that here in out. You have the ABI, you have the initial values for our storage, and we have the binary. As you can see, Sway storage is like a dictionary where you have like a storage key and a storage value, and for all of these is 0. And finally, we can deploy a contract. So let's do that by typing fork deploy dash dash testnet, just like that. That's how you deploy a contract. So I can do that. This is going to compile our contract once again. Tells us that we have some spam. Oh, give me 1 second, because we have some spam in Twitch. Twitch is somebody spamming there, so I'm not letting you do this. Let me come here to my own streaming. Oh, go back to chat. Hey, where's the chat? How can I delete this comment? Because I just opened the chat from the streaming, but I have like no access to the history. So, show me. Well, it seems like you did it, didn't you? Oh yeah, because I have to log in. Yeah. Oh, while I'm doing this afterwards. But yeah, Twitch, there's somebody doing a spam. Please don't do that. Okay, let's follow up. So finally, as a final step, we are deploying our contract. I just typed fork deployed testnet, and the CLI is telling me like, hey, you don't have a wallet, so would you like to have one? So I'm saying yes. They asked me for a password, so I'm adding some random password. And then they're giving me a mnemonic phrase. This is something you shouldn't be sharing with anyone. So I'm writing this here just for me. And yeah, I save this. Like in a real life scenario, you shouldn't be showing these words to anyone. Now it's asking me for a password for my first account. And finally, I have my account. So it's asking for the password one more time. So the deployment failed. Why? Because your wallet have no funds to cover for this transaction. So I can take my address. I can come here to I think it's this URL. Maybe in the documentation I have the URL, because yeah, we are here. Yeah, so if we come to the quick start and we go all the way below, we will find our faucet here. Yeah. So let me verify I'm a human being. Successful. I paste my own wallet. You're watching this, right? Yeah, you do. I'm not a robot. I know what a bicycle is. I know what a motorcycle is. This is like always the moment where you don't know like if you should be clicking this. Another motorcycle. So if you happen to be using a VPN, this is something common for you. Okay. Wow. This finally became like the captcha speed run. So yeah, we have some assets now for our wallet. So if I come back to my terminal, I can run fork deploy again. It's compiling again my code, asking for the password I have set for my wallet, and it's telling me like, hey, you have multiple accounts, so which one you want to use for signing? And I want to use account number 0, so I'm going to type number 0, enter, I agree, and there you go, we have a deployed contract. Woo! So this is it. If you want to go further and keep learning about your first Sway contract, you can come back here to docs.fuel.network guides/intro to Sway. And if you happen to be at this point, you will be able to go beyond the checkpoint. You have a deployed contract. So you have the Rust testing guide for this project, which is basically using Tokyo, like using cargo generate to get a template from GitHub, and then using Tokyo for the testing. So we are creating an instance of our contract, and then using that instance to start doing test cases, just like setting owners, or buying and selling items, and so on. And after having some testing in place, you can even move forward and start building a front end by using our TypeScript SDK. So for the Rust testing, we are using our Rust SDK, and for the front end, we are using our own TypeScript SDK. So it seems that we successfully did this workshop in 60 minutes, which makes me very happy. Unfortunately, we have a lot of pizza here, so we have to take care of that business. It was amazing to be with you today, but it's time to say goodbye. So thank you so much for joining today. This was Developer Aligned, Nerding Around Special Edition from Giveth House in Barcelona, and see you next time. Bye-bye.